Okay, 2.2b lesson is going to go really quickly because you've already done most of it. It's really just a review of 2.1c, as it says here. You're going to refer to that, but I think you're going to remember everything. So I just filled in that there are two new blocks being added to each stage, and you see that there are two here, two here, two here, and if we did a fourth one, there'd be two on the ends. And let's complete the table. So stage 1 has 3 blocks, stage 2 has 3 plus 2 more, which is 5, stage 3 has 1, 2, 3, 4, 5, 6, 7, right? Every time it goes up by 2. And that's something that we kind of already discovered before. And remember, if I always ask you guys to do this, is try to fill in stage 0. So if I added stage 0 here, you would see that it would just be the one here. And it still follows this pattern of 2 blocks per stage. So this is the question that is going to be the key to this whole section, is where is the rate of change in your table? And the rate of change, guys, is how much the blocks change per stage. So it's blocks per stage. And what we see is that every time we go up by one stage, we go up by how many blocks? And I'm going to draw these little triangles here. So this goes up by 2 every time this goes up by 1. And the pattern is the same. This goes up by 2, this goes up by 1. So if I write it as blocks per stage, it's 2 blocks per stage. And this table is the difference of this to this over this to this. Quickly create a graph of this data and see where we see the rate of change on the graph. So using this table here, 0, 1, as you can see, it starts at 0, 1 here, if I include that point. And then the rest of them, we'll just go ahead and fill in the values. For one stage, you have 3 blocks. For 2 stages, we have 5. For 3 stages, we have 7. And I'm going to answer this question by doing the next one without just looking at this point. I know it's 4, 9, but if I go like this, every time I go up a stage, I add 2 more blocks. In other words, I get 2 blocks per stage. So I'm kind of climbing the stairs there. So 4 is at 9. 2 blocks per stage. And this little drawing right here is really answering the question, is this little step and this step, these are all the rate of change that is being shown on the graph. So where do we see it on the graph? It's right here, these little indicators, 2 blocks per stage. Okay, the next question says, what is the simplified form of the equation that gives you number of blocks? If you remember, it's B equals, well, this right here, from 3 to 5 to 7 to 9, is our rate of change. So it's 2 times the stage, and it started with a head start of stage 0 up here. Stage 0 had 1 block. So 2s plus 1. That's the equation. And then where do you see the different parts of the equation in the geometric model, table, and the graph? Well, the geometric model, that's this guy. The table, that's this guy, and the graph, that's this guy. So right there, that 2 is the rate of change. And right here, this is stage 0. Okay. Where do you see this on the graph? Well, on the graph, right here, that point comes from that, doesn't it? 0, 1. Where does the 2 come from on the graph? Well, see this stair-stepping thing that we did here, the rate of change? All of that is the 2. So make sure you indicate that the rate of change, these stairs, is this number multiplying, and then this head start right here, 1, is where it starts on the y-axis. Okay. The pattern above is a linear pattern. In other words, it makes a line when we graph it. How does a linear pattern grow? It grows at a, well, doesn't it change at a steady rate? It has a rate of change. So rate of change. And describe what the graph of a linear pattern looks like. Well, obviously it looks like a line. Okay, it says use your word from lesson 2.1c to answer the questions below. And then we're going to complete this table and be done with this section. So we've already done this pattern. How many new blocks are added? Well, that's what these black ones are. Everyone, we add 3 new blocks per stage. If I was to add our little stage 0 here, look, if I add 3 blocks going this direction, if I take 3 blocks away, I'm just going to write -2 there, because if you have 1 and you're taking away from that 1, you end up taking away 3, I should say, you end up with -2. Let's complete the table. So stage 1 had 1, stage 2 had 1, 2, 3, 4, stage 3 had 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, and if we follow the pattern here, this is growing by 3, so stage 4 should have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yes. Stage 5 would have 13, and stage 0, -2. What am I doing right here? What am I showing right now? This is growing by 3 as this grows by 1. This right here that I'm indicating on the table, the growth of the blocks per stage is the rate of change. So blocks, 3 blocks per 1 stage. My rate of change is 3. Create a graph, so we just plot these points. So 1 block for 1 stage, stage 2. Up here is 4 blocks, and if I just do it now, I know that every time I increase 1 stage, I add 3 blocks. So 1, 2, 3 blocks per stage should match this table. So 3, 7, and of course it does. So 1, 2, 3 blocks per stage, 1, 2, 3 blocks per stage. And then the one that's tricky is the stage 0 here. Stage 0 is -2. So this graph, if it continued down here, I would have to be down here at -2. So kind of make sure you understand that this graph is not starting at the origin. It's starting down here. It wouldn't hit the y-axis until way down here at -2. Because look, instead of adding 1, 2, 3 blocks in per stage, if I go back 1, 2, 3 blocks back a stage, that's why it's down here at -2. So now we know all the information we need to write the equation. So the number of blocks equals, well, there's my rate of change, 3 blocks per stage plus my head start of -2. And remember where that -2 came from. That's stage 0. That's the rate of change. Okay, last page. Maybe you have to make this a little smaller, so zoom in if you have to. Complete the table below for b equals 3s minus 2. Describe each representation, geometric model, table, graph, and equation. Okay, so the equation, we're describing the part, what does this 3 in this equation represent in the equation? What's the rate of change? In the geometric model, this 3 means you're adding 3 blocks per stage. You're just drawing those additional 3 blocks. In the table of values, this 3 comes from this, if you guys know what I mean. What it means is, here's the x, here's the y, is the change of y over x. So how much does this y value change over that as a rate of change? And in the graph, the 3 represents, this 3 right here represents what on the graph? It represents the stairs. It's this change right here, the blocks per stage. Okay, so describe it. Well, it's the number of blocks per stage, and it's the steps of the graph. Okay? Alright, now let's go and talk about the -2. the -2 here, this number right here in the equation, well, what does the -2 represent? It's the head start. It's the stuff that's being added, or it's where it's being subtracted in this case. In the geometric model, the -2 is stage 0. In the table of values, it is also stage 0. And in the graph, this is really important. We're going to introduce another term here. In the graph, what does this -2 represent? If I flip back and actually look at it, this graph, if I look at this point right here, is where the graph hits this line called the y-axis. So I'm going to write down what I just said. It's where the line touches the y-axis. And of course, if that number is anything other than 0, it's not going to go through the origin. Okay, last question. Does the pattern b equal 3s minus 2 represent a linear pattern? Well, the question is, does this represent a line? And of course, we know it does. Yes, it does. And it's saying use the evidence from each of the representations to justify. So I will, since I'm running out of time on my video here, I'm going to let you look back and talk about why, of course, this represents a line. Well, first of all, every time we add a new stage, we add the same number of blocks. So that's the geometric model. In the table, you can see that the B grows at the same rate here every time as this grows by the same. So this is a linear pattern. The graph is obvious. It makes a line. Okay. So back up and rewind and watch it again if I went too fast. Thanks, guys.